This video is designed to help you prepare for our final exam this week and next week by reviewing the constructed response questions that you are going to see on the test. Before we get started, I want to thank you for watching and listening to the video. So I want to give you an answer to one of the questions on the final exam. Notice that I'm not writing this down because I want to reward those of you that actually listen to the videos. So on part 2 of the test that you will take next week, the answer to question number 21 is x minus 5 squared equals 17. So again, the answer to number 21 on part 2 is x minus 5 squared equals 17. And you will take part 2 next Tuesday, Wednesday, Thursday, or Friday, depending on your class period. But let's go ahead and get started on working on these constructed response questions. So the first constructed response question you are going to see on part 1, and it is going to be a question asking you to use vertex form. So vertex form is not something we've talked about before, but vertex form is y equals the quantity x minus h squared plus k, where your vertex is hk. So basically they're saying that when you write your coordinate pair for your vertex, where you have an h in this formula, you're going to put the x coordinate of your vertex. And where you have a k in the formula, you are going to put your y. Vertex form will be on your formula sheet. And you are going to be given a formula sheet before you take the test. So on your formula sheet, you will have to use vertex form. So part A says find the equation of the quadratic function in vertex form. And they're talking about this quadratic equation right here. On your exam, they will give you a graph, and they want you to convert this graph into vertex form. So again, vertex form is x minus h squared plus k. We'll put the y equals. My vertex in this parabola is this point right here. So we would label that point 3, 2. So my vertex is 3, 2. Vertex form, instead of using x and y, they use h and k. Don't ask me why. I have no idea. H stands for horizontal, k stands for vertical shift. I don't know where they got the k from. So in my equation, everywhere I have an h, I'm going to substitute a 3. So I have y equals x minus 3 squared plus, instead of putting k, I'm going to put my k value, which is 2. So all you have to really remember is that your vertex is hk. The h is replaced by the x coordinate of your vertex, and the k is replaced by the y coordinate of your vertex. Remember your vertex? The same way they could ask you that is for the max or the min, and we talked about that this week when we talked about the key features of quadratic functions. Vertex was one of them. The other words for vertex are maximum, minimum. This particular parabola or graph of a quadratic has a minimum value. This would be your final answer. Part B for the same question says find the equation of the quadratic function in vertex form after it has been translated 5 units down. So using this vertex, they want us to shift it 5 units down. So 1, 2, 3, 4, 5. My new vertex would be right there. So I'm going to say this is vertex number 2. So that is translated or shifted 5 units down. So now I'm going to do the same thing. I'm going to write the coordinate pair for this vertex. The coordinate pair would be 3, negative 3. Remember, instead of x and y, for vertex form, they use h and k. So vertex form is y equals x minus h squared plus k. I'm going to replace the h and the k with my vertex values that I found from the graph. So my h value is 3, So everywhere I have an h, I'm going to put a 3, so x minus 3 squared, and my k value is negative 3. So this would be my answer. For part B, on the first constructed response, all you're doing is taking your vertex values and plugging them in so you don't have an h and you don't have a k anymore. All right, so now we're going to talk about the second constructed response question you will have on your final. This question is also going to be on part 1 of the final exam. So you will see that either on Friday if you take me on A days, or on Monday if you take me on B days. So we have this system of equations, and the lines are really difficult to see. But on your final exam, you will be able to see all the lines for the coordinate plane. All right, we need to write what the system of equations that is represented by the graph shown. So they want to know the slope-intercept or the standard form for each of these equations. I'm going to label this first line A and the second line B, just so we know which lines we're talking about. So my first line is this darker line. So for line A, I need to write this equation in slope-intercept form. Remember that slope-intercept form is y equals mx plus b. So I need to find my m and my b value. So m is your slope, and we find that using rise over run. So they give me 2 points, this point and this point. -1 would be that. So I would rise 1, run 1. So my rise would be 1, my run would be 1. And my y-intercept would be -1. My y-intercept is right here. That value is -1. Again, I know it's difficult to see. For B, now we're looking at this line. Oh, let's go back. Let's write this equation. Y equals, and now that I look at this, let's see, this would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This would probably, let's use these 2 points instead. So instead of rising 1, running 1, it would rise 1, 2, 3, run 1. Those would be more perfect points. So my slope would be 3, my y-intercept would be 1, so I'd have y equals 3x minus 1, and then minus 2, minus 3, minus 4. For B, my y-intercept is -4, and my rise is 1, so I'm going from this point to this point. 1, 2, 3, 4 over 1. So what my m, or my slope, I count my rise and my run. So I'm using this point here and this point here for line B. I rise 1, 2, 3, 4, and run 1. My b value is my y-intercept, which is down here at -4. So for b, it'd be y equals 4x minus 4. So on part A, they just want you to write the equations for both lines shown. And again, on your final, the lines will be more clear, the points will be more clear. The copier just didn't like me and did not plot the lines. Part B asks what the solution to the system of equations written in part A. So we just wrote these equations, but if you're looking at this graph, remember that the solution is where the lines cross. You could approximate that they would cross somewhere up here, but we need to find out what that exact point is. Because you have two equations in slope-intercept form, you could go to Desmos and then graph both of these equations. So remember, you can go to Desmos, and when you get to Desmos, you could graph both of your equations. So we said y equals 3x minus 1. And our other equation is y equals 4x minus 4. And we can see that they cross at this point right here, which is 3, 8. The other way you could do this is algebraically, you could set these equations equal to each other. So you could say 3x minus 1 equals 4x minus 4. And we're going to solve for x. So we add 4, add 4. That cancels out here. 3x plus 3 equals 4x. Subtract 3x, subtract 3x, cancels out. 3 equals 1x. Trying to get x by itself. Divide by 1. So x equals 3. Oh, and you can't see that. And then once you know your x value, you could plug it in to solve for y. So then we would have y equals 3 times 3 minus 1. I'm using this equation right here. Everywhere I have an x, I substituted a 3. 3 times 3 is 9. 9 minus 1 is 8, so y equals 8, which would give me the coordinate point 3, 8. Make sure that your answer is in a coordinate pair. You will only get full credit if your answer is written as a coordinate pair. So I just told you two different ways. You can do it algebraically by setting both of your equations equal to each other, or you can use Desmos to graph both of them and find their intersection. Either way, you should get the same answer. All right, the last question we need to look at is on the back. And this one has 4 parts, and this question will be on part 2. Again, my copier did not like me when I was copying this. So it looks a little crinkly, but we'll get through it. Alright, it says the function y equals negative x minus 2 squared plus 4 can be used to represent the height of a soccer ball in feet in x seconds after a player has kicked the ball. So we're thinking about a soccer ball that has been kicked up into the air and then comes back down. Alright? And they said solve this equation to find the zeros of the function. So zeros, is this what this says? And you should be thinking, oh, I know that zeros also means x-intercepts. We talked about that this week in class. So then if you went to your Desmos, let's see, we can graph this equation. So negative x minus 2 squared plus 4. And here is our graph. All right, so they want the x-intercepts. So for this one, I have an x-intercept at 0, 0, and an x-intercept at 4. So go ahead and jot those down. 0, 0, 4, 0. So my answer here would be, this was 0, 0, and this was 4, 0. So the solutions are x equals 0 and x equals 4. Those would be your two answers. Explain what the zeros represent in the context of the problem. So in this problem, my x-intercepts is when the ball is on the ground. At 0 seconds it was on the ground, then it went up in the air and came down at 4 seconds. Part C, are both zeros reasonable in the context of this situation? So for this situation, yes, because both are positive. And time can only be positive if you get a negative x value. So if this is x equals negative 4, that makes no sense because you can't have negative 4 seconds. And the last thing they want is the y-intercept. you'd have to go back to Desmos, find that, and that would be your